Hello everyone, and thank you for coming to my talk. Today we'll be chatting about the OWASP top 10 that is specific to mobile applications. And in particular, we're going to be talking about how to fix all of the vulnerability categories in that list. Now, if you're not familiar with the OWASP top 10, it's a list of 10 vulnerability categories that tend to be the most dangerous or the most common. And you're most likely familiar with the generic version of that. This is just the mobile take on it for talking about platforms like Android and Apple. And for the mobile OWASP top 10, there are two different lists, the 2014 list and the 2016 list. For this talk, we'll be covering a few from both, and there's a lot of overlap between them, as you might expect, so I'll be condensing them if necessary. I'll also be removing a lot of the content that is covered in the original OWASP top 10, because I'm assuming you have at least a little bit of familiarity with that, and if you're not, it's publicly accessible material. So for me, I'm Garrett Mosier. I am a former software engineer and recently made the transition into application security, where I'm currently at Toast. And in my free time, I enjoy playing Go and hockey. Right, so now to jump into the core of the talk. First off, we're going to be discussing improper platform usage, which is from the 2016 list at the very top. And this is going to be talking about mobile platforms which happen to have a specific feature, which you might be aware of. Common use cases of this would be Touch ID, keychain of both Android and Apple, as well as Android Intents. And it's important to note that not all vulnerabilities you might find in this category are the developer's faults. It's entirely possible that it could be on the platform itself. In my personal opinion, an example of this would be using immutable data, such as fingerprints or facial ID, for authentication, especially as passwords. This is problematic in my opinion because those leaks can't be fixed. Unlike using a password manager to automatically regenerate a password, should there ever be a password leak on your favorite site, you can't regenerate your own face or your fingerprints. So in order to remediate this, the main thing you're going to want to do is to read the recommended guidelines for whatever platforms or libraries you're using. Chances are they've had security engineers look through a lot of these common issues and are going to give you very apt recommendations on how to best use their particular platform. And they'll also very likely have concrete patterns as well as code samples that you can put into your code that will get you at the very least most of the way there, if not entirely there. Next up, we're going to be talking about insecure data storage and unintended data leakage. These are both on the 2014 and 2016 lists. And the core idea here is that mobile app data can be taken fairly easily, both through physical access, like stealing your phone at a bar, or through malware. Unlike a lot of servers, you don't control the platform itself, and a user can install any application from anywhere. So you have to be aware of the fact that they might have malicious software on their device. In order to fix this, the key thing is to not store data at all. The vast majority of applications don't require internet access to be used. And if they require internet access to be used, then the requirement to have a local copy of all that data becomes significantly smaller. However, if you do have mission critical data that must be on there, especially if you support some form of offline mode, you're going to want to ensure that you encrypt the data. Most platforms are going to have recommended patterns, going back to the previous slide. So I would recommend looking at those for whatever the platform you tend to use. Along these lines, you also really want to have some sort of credential removal plan for whenever your phone is stolen. This is particularly important for corporate applications because there might be sensitive data on servers that the user can have access to. So you want to have a very easy way to remove access to their old phone and then reinstate access with their new phone whenever they get that. It's also really important to threat model any form of non-traditional storage systems. Examples of that would be logs, caches, and analytics. These are systems that you don't tend to think of when you look at security. However, it's very easy, especially for developers, to do a simple data dump and find out that there's very sensitive information being put into those logs or caches that are pretty easily accessible by malware. Next up, we're going to be talking about client code quality, which was number 7 on the 2016 list for mobile OWASP. And this is going to be passing unvalidated input to mobile functions. The primary use cases they talk about in the list itself are buffer overflow and memory leaks. I'm hoping this is largely because this is an older list, so about 4 years old, and a lot of these issues have been solved through more modern languages like Swift. which is why for remediation, you just don't want to do your own manual memory management or really deal with buffers if at all possible. It's kind of like crypto in that if you roll your own, you're very likely going to make mistakes, so rely on experts to do that for you. Thankfully, most modern languages frameworks have something like that, so just use them by default. If you are happening to use older systems that maybe require more manual memory management, that's when you would I would highly recommend you upgrade to newer systems so that you can have all that capabilities for free. Next up is code tampering, also known as lack of binary protections. This is when you take an application that someone else developed and put malicious code in it. And unfortunately, this is really easy to do and really difficult to protect against, because pretty much any app store is going to allow you to easily download the binary, and there are all kinds of deobfuscation tools to get the source code into some kind of meaningful way that an attacker can mess with. And in order to get this malicious application on someone's phone, you can use standard techniques like phishing. You can have a third-party app store that looks legitimate, or you can just give the user a link to an executable such as an APK. In terms of remediation, there are a few things you can do. One is running a checksum to ensure that the code hasn't been modified at all. Usually, if you take a checksum of the code when it is deployed, you can check that against the current instance of the code, and if those don't match, then it's highly likely that it's been modified in some way, and you shouldn't either trust it at all or possibly even don't run it, depending on your stance. You should also authenticate at all points between the server and the application. This is good practice for security generally. However, it's particularly important for applications because they're often assumed to be trustworthy by default, and it's definitely not true in this case. You also want to check to see if the device is jailbroken or in a debugger. As technologies evolve, it can become a little bit more difficult to tell if it's a jailbroken or if it's in a debugger, but if there is a good technique you happen to have found, then I would recommend that, because most quote-unquote normal users won't be using it that way. Next up, we're going to be talking about reverse engineering. Similar to the previous one, this is when an attacker can get direct access to your code through the binary, such as an APK. That's often going to be on a primary app store. And analysis tools can convert even very well obfuscated code from something like APK into meaningful Java. And because of that, security through obscurity doesn't work here, because an attacker can see all of your code. It may not have the exact same variable names, but it's going to be more or less the exact same, and they can do a lot with that. So the two main things you want to do are obfuscate your code deployment. I won't recommend any particular tools. However, there are many that are out there, and they do tend to do pretty good work. So just do your due diligence, find the best out there that works for you. And secondly, is make sure you don't hide anything in the code like secrets. Although it's generally a bad idea to do this even on server software, because it is so trivially easy to get admin passwords or anything else you might not want to have been found on an application. It's doubly important not to have that and to store it elsewhere. Next up, we're going to be talking about extraneous functionality, which is number 10 on the 2016 list. And this is primarily focusing on dead code. Pretty much all software that's been around for more than a week is going to have code that is not directly used, or maybe even was used at one point, but is no longer used. And this is important, primarily because it can expose a functionality that shouldn't be, either through the application itself or through unused endpoints on the server that have been shut down. And that's important because a lot of these older legacy endpoints that we thought should have been shut down don't have the same security updates for the primary version. So in order to prevent this, you just don't leave the application in the old state. If you ever have dead code, remove it. There are plenty of analysis tools that can do a pretty good job of finding any code that may not be directly accessed. So if you can use that, you'll do a pretty good job. And it's just developer friendly because the larger code bases, the more complicated it is, and you want their lives to be as easy as possible as people in AppSec. And it's also important to remember that if you're using version control to Git, you can always revert it. So even if you are a little bit overzealous in removing code that you don't think is going to be used, or maybe it might be used in the future, you can always go back in time, grab that code and put it back should you ever need it. Next up, we're going to be talking about client-side injection, which is number 7 in the 2014 list. This category is primarily about the injection attacks we know and love, like SQL. However, specific to mobile, the list calls out file access issues. You really want to prevent directory manipulation from user input. Very similar to some of the attacks we see on PHP servers, where you can access the file structure itself on the underlying server. You can often do something very similar with most mobile phones. So in order to prevent that, you want to, 1, validate all input and output. I'm personally a big fan of strong typing. If you are expecting an int, ensure you actually have an int. And if that doesn't work or is insufficient, as it might be, like if you're dealing with generic strings, you want to really heavily disable or restrict any file access on your application. More often than not, your application doesn't need to do anything terribly complicated with the file system. So if you just want to make sure that it can't happen, because it doesn't really benefit you, and it would only benefit the attacker should they ever get access to it. Next up, we're going to be talking about security decisions through untrusted input, which is number 8 on the 2014 list. This is pretty similar to client code quality, which we were talking about before. And it's primarily about passing in sensitive data to mobile-specific functions. The list specifically calls out inter-process communication, and that is very dangerous because it's often trusted by default. You very rarely know exactly where the data came from, if it does come through IPC, or if it's been modified at all. So you want to be particularly careful about that. The 2 main recommended remediation techniques for this are to, 1, require user interaction for any security-sensitive tasks. For example, if you need to log in, make sure that you actually have the screen pop up for the user. Although this may be a little bit more complicated and more effort on the user's part, it's going to prevent a lot of issues should other applications try and do something security related in the background without the user knowing. And the other part is to never pass sensitive data, such as PII, through the IPC. You don't necessarily know where it's being passed in or where it's being tracked, so it's just a good general practice to not send it there at all. All right, that was my talk. I really want to take the time to thank you all for listening to it. I believe we have a few minutes for question and answer after this, and I would